So in the previous video we talked about using the switch statement, and in this video we're going to move on now and talk about the for statement. And the for statement is used to loop some code. So it's, in other words, it's going to allow us to execute code a certain number of times. Now we haven't really looked at that before, and looping code, in other words executing code more than once, a number of times, is something that is very commonly needed in programming. And I'm going to show you an example of why we would want to do that. So I'm going to start off by creating a new method. I'm going to call it public static double calculate interest. And the two parameters are going to be double amount and double interest rate. So this is going to calculate the interest based on the amount of money that's passed as a parameter. Now, one way to do this is going to be just to do something along these lines. We're going to do a return amount, whatever the amount is, multiplied by the interest rate, divided by 100. And what we'll do is we'll put another bracket in there just to make sure from an operator precedence point of view that we're processing it correctly. We're actually figuring out the amount and then multiplying it by the interest rate divided by 100, and things are being calculated in the right order. Now what we'll do is, just to confirm that this is working, we're going to just create a sample bit of code and we're just going to call it. So we're going to put 10,000 at 2% interest equals, and we're going to call that method. So calculate interest, and we're going to pass 10,000.0 and 2.0, which is $10,000 for our test amount, and 2.0 is 2%. So let's just run this and make sure that it does work. And you can see we're getting 200.0 there. Then that 200.0 means it's $200 would be the 2% interest. Now, this doesn't take into account anything like compound interest or the amount of time to pay off the loan or anything like that. It's just a very simple contrived example of calculating some interest on an amount of money. Now, this is one way to do it, but let's just say we wanted to calculate 3% and then 4% and then 5%. Perhaps you're doing a comparison with different places and you want to calculate a number of them. So you could see that we could do it one way. We could copy this, we could paste this like so, and we could change the printout to say 3%, 4%, 5%. And we could change the parameter to be 3%, 4%, 5%. So we've now got, if we run this, 2%, 3%, 4%, and 5% calculated, which is $200, $300, $400, and $500 respectively. But you could probably see straight away that that would get really tedious. Now, if you had to do that every time you wanted to calculate a different interest rate, it would be, as I said, very tedious. And what about if we had 20 interest rates or 100 interest rate calculations we wanted to do? You could see there'd be lots of code, and it's very inflexible because you're continually having to go back and change things, and it's just going to be mountains of code. Well, the good thing here is that computers are made for automation. So this is a good there's a good solution to getting around this problem, and that's using a for statement to automate this process and ultimately to make it a lot easier. Now, the for statement is often referred to as the for loop. And the idea is that it repeatedly loops something until a condition is satisfied. When I say repeatedly loops, it's processing a certain amount of code, a code block in other words, a given number of times or until a particular condition is satisfied. So the basic structure is something along these lines. We type in for, and I'm just going to put these three things in and then we'll discuss them. That's the basic format of a for statement. So we've got the for, we've got brackets, and we've got init. Init means the code that is going to be initialized once at the start of the loop. Termination is telling us, or what we do is we tell the for loop how we want to exit. So at what point do we exit? And that has to evaluate to false. And once it evaluates to false, whatever that condition is we're going to put in there, the loop will then exit, and we'll come down here and start processing on the next line. An increment, that's an expression that's invoked after each iteration of the loop, so each time the loop goes round. So a common thing to put in there would be a number that is incremented each time. So it's sort of like a count. So what we're going to do is just write a very simple example, then ultimately later in this video we're going to call this calculate interest method. So this is how you would start. You type something like for, so we need an initialization. So a common thing to do there would be to initialize a variable. So let's put int I equals 0. So you've seen that before, a data type and then the variable. We probably haven't seen it in a loop like this, but what we're doing is we're initializing a special variable just for this loop. Once the loop is exited and finished with, this variable won't exist anymore. So it's really just for the for loop. Now the termination, so basically that has to be false before the loop will finish. So what we'll do there is a good way of doing it would be to put I less than 5. So you can see by putting I less than 5, the first time we run it, I is 0. So I is less than 5. Well, that's going to be true at the moment. So, and the loop is going to continue working until it's false. So in this case, it's going to be true for the first time. So it is going to work, and it's going to, whatever the code we're going to put in here is going to be actually executed. An increment, well, what we want to do there at the end of each loop, we want to increase the value of I, and we can do I++ to do that. So you can see now that we've got, we're setting our initial variable I to 0. Our test is to confirm that I is less than 5. So in other words, it's going to keep processing until I is 5 or greater. And I++, each time we go through the loop, we're adding 1 to the value of I. So just to confirm that, let's actually put something out. We'll print something out in here. So we'll put loop plus I plus, let's just put something like hello. So now we've created a loop, and the loop consists of a code block that's only got one statement, which is an output that's going to print the value of I and print a message, and it hopefully should go through each time through the loop and print out a message each time it goes through. So let's run that. So you can see what's happened here, loop 0, hello, loop 1, 2, 3, and 4. So you can see what's happened. We started on I equals 0, and we've moved on until we've got to 4, and then what's happened was the next one's come through, and I was the value of 5. Our condition to check was I less than 5, and that then turned false because I was 5, and then the loop exited, and then we come down to here, and of course there wasn't any other code, so the Java application finished. So you can see that the computer has executed the code 5 times, starting at 0. Now 0 is just a value there. We don't have to run it. We don't have to start at 0. We could change it to anything. So we could change it, for example, to 1. And if we run that, you can see we've got 1, 2, 3, 4 this time because we started from 1, but this time there's only 4 loops because the first time was looped, the value was 1, second time it was 2, third time it was 3, fourth time it was 4, and of course the fifth time I was in fact 5, and it's not I is not less than 5 at that point, so the loop exited. And of course if we wanted to run it 5 times, we could change that to say 6. 1, 2, 3, 4, 5 again. We've got it to run again 5 times. But it is fairly typical in these scenarios with for loops to start with 0 because a lot of Java different parts of Java which you'll be finding later in the course, for example arrays, start at 0. So it's a good habit to get into with your coding to start things at 0 because you'll see that a lot in the course later on, that many computer languages including Java, they start their counts at 0 and not at 1. Okay, so I've got a mini challenge for you at this point. I'm going to paste this in here. So using the for statement we've just learnt about above, I want you to call the calculate interest method with the amount of 10,000 with an interest rate of 2, 3, 4, 5, 6, 7, and 8% and print the results to the console window. So you should be able to figure that out based on lines 6 through 9. And how to call the calculate interest method, and also the loop that we've just learned about. So type that code below this and pause the video now and come back once you've got a solution, and then I'll actually type in the code that I've come up with and you can compare your results to mine. So pause the video now. Okay, so how did you go? Hopefully you figured it out, and what I'm going to do now is show you how to do it. So what we need to do first is obviously a for loop. So we went to looking at what we want to calculate, 2, 3, 4, 5, 6, 7, and 8. So obviously then we want to create a for loop for, we can start I equals 2 because that's our first one we want to start with. So when you're doing a for loop, you start with the first element number you want to start with. In this case, it's 2. And then we can put I, and we want to go up until 8. So therefore our test should be 1 more than 8 because we want to process 8. I less than 9 would be our test. So once it hits 9 or it's greater than 9, it's going to exit the loop, and I'll set that up to int again, and we'll just use an I++, And incidentally, you notice how we can reuse the variable again. And that's what I mentioned that earlier, that the variable that you create here in this for loop only exists for this code block, for the code block that's in the for loop. As soon as you exit that variable doesn't exist anymore and you can reuse it. And it is also very common, just to let you know, in for loops and while loops, which you'll learn in the next video, to use variables like I and J and K and so forth, because they're just there as basically indexes to loop through a number of times. So if you see I, J and K and you're wondering, well, Tim, why aren't you creating better variable names? It is very common to use those in loops such as this. Okay, so next thing we need to do is we just need to print out a message. So what we can do is just take a copy of this line. I'm going to paste that in there. And what I'm going to do is change the 2.0 to I. Now you'll notice that if you're looking at this, you probably notice, well, this is an integer, but this is a double the interest rate. So that's correct, but what Java is doing, Java is smart enough to know that, okay, I can convert a whole number, an integer, to a double. So it's doing that for us automatically. Now what you could do if you wanted to be correct, you could cast it as a double there, but it isn't necessary to do that. It works quite nicely without it. And of course the other thing would be if you in fact wanted to calculate interest rates with percentages, then you probably wouldn't be using an integer there, you'd be using a double, and you'd actually have a different way of incrementing. Like for example, you could increment by 0.5% or something along those lines. But in this case, we're keeping it pretty simple. We're using integers and we're going through the looping like that. So let's now run this code. And you can see there we've actually got our solution working. We've got 2, 3, 4, 5, 6, 7, 8. So in other words, 2 through 8 were actually calculated correctly. And what I didn't do was update the printout for that. So let me do that. We'll put plus I plus like so. Let's run that again. And there we go, 2, 3, 4, 5, 6, 7, 8, which is what we needed to do in the challenge. We needed to actually calculate the interest rate on 10,000 on all of those, which we've done. So that's the result of the challenge. And one thing you probably noticed here is that this has got a lot of decimal points. Well, sometimes in terms of the precision of a double, it will calculate things like this, and it's not something you need to worry about. We'll be talking about precision later in the course, but it can be nice to actually get rid of that so it actually outputs in a nice way. So one thing you can do there to fix it up if you do want to do that is we could actually come in here and we could type string.format %.2f, comma, and then I'll just add another bracket on the end. Now, this is not something you need to do, but what's happening here is we're passing the value that we got returned ultimately from our calculate interest method to the string.format command. And what that does, the %.2f in this case means output the number or convert the number and output it with just 2 decimal points. And that would then guarantee that we don't get all those zeros. And it means instead of seeing 200.0, 300.0, we should be getting 2 zeros. So let's just try running that. You can see we've now got it correctly formatted 2, 3, 4, 5, 6, 7, and 8. And you can see the examples at the top there only had the 1 decimal point. So that's one way to look at doing it as well. But it's not something you need to worry too much about, but I just thought I'd put it in there now in case you're wondering how to go about doing that. Okay, so next mini challenge. So how would you modify the for loop above to do the same thing as shown, but to start from 8% and to work back to 2%. So in other words, the first time it runs through the loop, it should be 8. The second time it should be 7. Third time it should be 6. So what I suggest you do is copy and paste the code above down here, and then try your results. So that way you keep the original code up at the top there. So pause the video now and see if you can figure that out, and come back and I'll show you how to do it. Okay, so hopefully you managed to figure it out. So what we'll do is we'll copy it, as I mentioned. Now instead of putting for I equals 2, well, we want to start at 8%. So clearly, just we talked about before, what we start on is always going to be the variable value initially. So it's going to put 8. Now we can't put I less than 9, can we? Because obviously in the first case, I equals 8, it's going to work, but it's going to be sort of literally going the wrong way. So what we really want to do here is change this around how it's going to end. So where it should end effectively should be its I is greater than or equal to 2. In other words, it's going to keep processing while up until I is greater than or equal to 2. And then the last one, well, we want to go backwards this time, so we want to do I minus minus. So you can see I equals 8, I greater than or equal to 2, I minus minus, that should go back in the backwards direction. So let's try running that. And what we might just do is just put a message here just to separate it, just so we don't get confused with the output from the previous for loop. We run that. And you can see now we started at 8%, 765432, so it's gone backwards. So again, you can have a loop to go either forward or backwards. It just depends on the conditions that you're typing in there, and you just need to make sure you get your ranges correct. And if you do get those numbers wrong, and I probably haven't got too much time to go into that in this video, you'll find that often the for loop may lock up. It may not, and it'll continue looping, it won't exit, or you might find it doesn't execute at all. So make sure if in those situations, just check your initialization variables, but also this condition here as to when it will exit. That's really the key in many ways to the entire loop, is what your condition is, what needs to be false to be able to allow the loop to exit. Okay, so what I'm going to do now is finish off with a challenge for you, one other final challenge. And in order to do that, what I need to do is give you a bit of code. So I'm going to give you some code to generate a prime number. Then I'm going to go through that quickly, because it's not really important to know about that, but you need to do some coding. You need to come up with some code that calls this on a particular amount of time. So I'm going to paste that code in and just talk about it briefly. So this is a function that's going to determine whether a passed integer is a prime number. And I'm not sure whether you know or not, but a prime number can be divided evenly only by 1 or by itself. And the other thing is it has to be a whole number greater than 1. So this particular function, what it does, firstly it tests to see whether it's 1. And if it is the number 1, it's just going to return false, because a prime number can only be divided evenly only by 1 or itself. And it has to also be a whole number greater than 1. So if it is 1, we're returning false. We don't need to do any other processing. And in terms of the for loop, I wanted to also show you how this for loop is a little bit different. So we've got for int I equals 2, we're starting on 2 because I remember I said that a prime number has to be greater than 1. And now we did that test on line 35. Okay, so you can see there that we've got our loop there. We're just using n divided by 2 as a shortcut, because what we're attempting to do is find numbers that divide into n. So this for loop is only going to go through and really calculate what it needs to do. So no number that is greater than n divided by 2 is going to divide into n. That's really the point here, that by dividing it by 2, we're just really optimizing this to make sure that we're not actually processing numbers we don't need to process when we're checking. And this code on line 40 is then checking whether n, the remainder between n and I, dividing I into n, if that's 0, it means there's no remainder. So what that essentially means at this point is we've found another number that divides evenly into the number that was passed, and therefore this can't be a prime number. So we need to go through the whole loop. Once we've been through the whole loop, we can return true, because at that point we've determined it is a prime number. So that's all the n divided by 2 is there. It's just really an optimization technique just to save a bit of time for the computer. And again, we're just checking for the remainder. And if we find that there's another number that evenly divides into the number that's passed, it means this can't be a prime number. So that's what that method does. So what I'm going to do is just give you a final challenge to do now. So I'm going to come up here now that we've written that. So you'll need that method obviously, and we'll paste the challenge in, and your challenge is to create a for statement using any range of numbers, doesn't matter what they are. Determine if the number is a prime number using the isPrime method that I've given you down below. Now if it is a prime number, print it out and increment a count of the number of prime numbers found. Now if you get to the stage where 3 or more are found, in other words you've actually gone through the loop and you've found 3 prime numbers, I want you to exit the for loop. And as a hint, use the break statement to exit the loop. So you need to use an if statement to check, count, and then use break, and that will break out of the for loop for you automatically. So that's it. See if you can figure out that challenge. Pause the video now and do that. And once you're ready to see my version of the code, come back and we'll type it in. Pause the video now. Okay, so hopefully you managed to get it to work. So let's go through now. I know this video is getting long again. See if we can finish this off. So we're going to start off. I mentioned that we need to have a count. Determining we're going to exit if the count is 3, so we need int count, we're going to call it count equals 0. That's going to be our count, so the number of prime numbers that are found. So we now need to create a loop and go through and call this isPrime method a number of times. So I'm going to put for int I equals 10, and what I'm going to do is I'm going to go between I and 10 and 50. You can go through any range, it doesn't really matter, but I'm going to use 10, start on 10 and keep processing till we get to 50 basically. Once we hit 50 we're going to exit, and that's if we haven't found 3 prime numbers by then. So what we're going to do now in our loop, the first thing we're going to put is if is prime I. So if we have found a prime number, it's returned true, which you talked about the is prime method. So if we've found a prime number, what we want to do is do a count plus plus. Then we're going to put number plus I plus is prime number. At the point we've established that I is a prime number. And then we're going to put a test in here. Remember I said to use the break statement. So we're going to put if count is equal to 3. And I'm going to type in exiting for loop. And then I'm going to type in break. And that should be it. So we're going through a range of 10 through 49 basically, because once it hits 50 it'll exit. We're checking to see whether the prime number for the value I is a prime number. If it is, we're going to increment the count and we're going to print out a message saying that that number is a prime number. And if we've got 3, if and only if we've got to 3, then we're going to exit. Otherwise it's just going to continue. So we shouldn't see any other output unless we've found prime numbers. And the best way to do this now is to actually run it. So let's just run it and see whether it works. So number 11 is a prime number, 13, 17 is a prime number. You can see we're exiting the for loop. So we successfully finished after 3. So that seems to be working. So let's just go and make sure that they are prime numbers. So I'm just going to open a browser and do a list of prime numbers. And there's some there. The first 1,000 primes, that will be all we need. So let's just open that page up, that link up. You can see the link is up the top there. Or actually you'll see it once I get to it, the page. Seems to be taking a while to load for some reason. There we go. 2, 3, 5, 7, 11, 13, 17, 19. And I think if we go back and look at our code, 11, 13 and 17 is correct. So let's just change this just out of interest a little bit. Let's put the count to 10 instead of 3. And hopefully it will show us 10 prime numbers. And 11, 13, 17, 19, 23, 29, 31, 37, 41 and 43. They look good. They seem to be the right prime numbers there. So it seems to be working, which is good. So that's our challenge done. So the big thing there again was once we got to the count, whatever the count was that we decided we wanted to exit, we printed out the message and then we did a break. And the break actually exits out of the for loop completely, and processing will then continue on line 41 if there was any code there. But in this case, it was the end of the program. So that's what the break statement does. And that's it. So I'm going to finish the video here now. Just one really quick thing. There is a way also to optimize this, because we talked about optimizing I less than equal to n divided by 2. There is another, without going into too much detail, we could have actually changed that. So we could have actually used a square root. And the advantage of doing that would be that there's less processing still and it would be slightly faster. So without spending too much time explaining why, because the video is already too long, we could have done something like this. Long math.sqrt square root n. We're using long because the output that comes back from maths.square root can be large, so we can casting it as a long depending on the number. Now we wouldn't need to do that for the small numbers we're using here, but that would be a little bit more optimized. So if I run that, we should get the same results. Firstly, you still got the same results, but that would actually be better because you'll find that the number of things we need to check would be less. So be less times through the loop, so to speak. So you could test that if you wanted to. You could actually put some code in here to print out each time you're going through the loop and to test your results as to how many times. Actually, we'll just do that really quickly now. Let's just do that. We'll do let's just do that. So let's just, for the last one, for the number 41, 1, 2, 3, 4, 5, 6, that's 6 loops. Remembering that for the number 41. So if we change that back to n divided by 2 again. Now look at number 41 this time. Look at how many times it's actually had to loop through, significantly more times to calculate that number. So that would be the reason that you'd use that square root function for optimization purposes. But again, you'll find out more about using those sorts of things later in the course. I just wanted to point out there is another way of doing that if you decided to. But that's it. So that's the for loop. I hope you've got a lot out of that. And just one last thing, there's also another variation of the for loop called the for each. But we're not discussing that here, and the reason for that is we really need to be talking about arrays and objects and the like before that makes sense. So you'll see the for each, which again is a variation of this for loop in future videos in the course. So that's it. I'm going to end this video now. In the next video, we're going to start talking about another type of loop that's available in Java, and that's the while and also the do while. So I'll see you in that video.